right, now going to section 7.4 video. And in this video, we're going to talk about adding and subtracting with radical terms. Adding and subtracting with radical terms. Before I do that, I want to go back and remind you of something that we covered back early in chapter 5. It was somewhere, I think it was section 5.3. 5.3 and 5.4. I think it's 5.3. Where we were talking about adding and subtracting polynomial terms together. And whenever we covered that, I talked about the word like terms. Now, let me remind you of what like terms were. Like terms were two terms that were exactly the same except their coefficient. Now, what do I mean by coefficient? The coefficient is the number that's in front of all of it. And remember, if there's no number written, it's understood what? 1. Okay, so the coefficient of a term is the number that precedes the whole term. Now, what is like terms? It's two terms that are identical after the coefficient. So the coefficients can be different, but everything else behind that coefficient has to be the same. So let me remind you. Like 7x squared minus 11x squared. These are the coefficients. They are like terms because what's behind the coefficients are exactly the same. These two, 5a squared plus b plus 3a squared b. These two terms are like terms because here are their coefficients, and what's behind the coefficients are exactly the same. Now, remember, when you're adding like terms, the like term doesn't change. You'll remember me saying when you add apples to apples, what do you get? You get apples. You don't get oranges. When you subtract apples and apples, you get apples. So when you do 7x squared minus 11x squared is negative 4x squared. 5a squared b plus 3a squared b is 8a squared b. Now, it doesn't work that way when you're multiplying those two terms, but it does when you're adding and subtracting. Now, when we get to these next two terms, I can't subtract these because they're not like terms. I can't subtract these because they're not like terms. Now, let's go now to radicals. Let me talk about first what the coefficient of a radical term is. The coefficient of a radical term is the number that is in front of it. It's not the number under the radical. Remember, what's under the radical is called the radicand. R-A-D-I-C-A-N-D. I showed you that when we first started radicals on videos. So if I write this, 5 square root of 3, this is the coefficient right there. Or if I have negative 4 square root of 11, negative 4 is the coefficient. Or if I have square root of 3, 1 is the coefficient. So, when you're adding and subtracting with radical terms, they have to be like terms. So here's what that means. It means if one of your terms has a radical in it, the other one has to have a radical in it. And not only does it have to have a radical in it, what's under that radical has to be the same. For instance, question, 7 square root of 3 and 2 square root of 3. Are these like terms? Yes. Why? Because there's their coefficient, 7 and 2. What's behind this coefficient? Square root of 3. What's behind this coefficient? Square root of 3. Is what's behind this term, behind this coefficient, behind this coefficient? Yes. Then those are like terms. If I have this, 5 square root of 3a and negative square root of 3a. Are these like terms? Well, let's look at the coefficients. What's the coefficient? It's the number in front of everything. 5. What's the coefficient over here? -1. What's behind this coefficient? Square root of 3a. What's behind this coefficient? Square root of 3a. So are those two terms like terms? Yes. So what does that mean then? It means you can add and subtract them. Now, how do you add and subtract them? You add and subtract them the same way you do these two. You add or subtract their coefficients. But what's behind the coefficients doesn't change. What's behind the coefficients doesn't change. You just simply add or subtract the coefficients together. And then whatever's behind those coefficients, you copy back down. So, let's do some examples here then. So if I have, I'll tell you what, let me just put this up. And I'm going to let you copy all of this down, and then I will cover it up. So pause the video, give me just a second. Pause the video now and copy this down. Okay, I'm assuming you did that. Now let me cover this up right here. And I'll go over these one at a time. Okay? 7 square root of 3 plus 5 square root of 3. Are they like terms? Yes, they are. Why? Because the only difference is their coefficients. So, if they're like terms, you just add the 7 plus 5. What is 7 plus 5? 12. But remember, when you're adding the like terms, when you're adding apples to apples, you get apples. So when you add square root of 3's to square root of 3's, I have 7 square root of 3's plus 5 more square root of 3's, so I have a total of 12 square root of 3's. Not 12 square root of 6's. You do not add what's under the radicals. You add their coefficients, but this stays the same. That's why they have to be the same to begin with. Okay, so the next one, 6 square root of 2 minus 9 square root of 2. Are they like terms? Yes, they are. So 6 minus 9 would be -3. And then still be square root of 2. Now this next one, there's 3 terms. Excuse me. Okay, so we've got 8 square root of 7 plus 2 square root of 7 minus 3 square root of 5. Well, these two terms are alike, but this one's different. So add these two together. 8 square root of 7 plus 2 square root of 7 is 10 square root of 7, and then just bring the minus 3 square root of 5 across, because it's different. No, you cannot subtract these. Okay, let's look at this next one. Square root of 7 plus square root of 7. Can't tell you how many times I see right here for this answer. I'll see square root of 14. You don't add what's under here. Never. What you ask yourself first is, what are the coefficients? 1 and 1. Is what's behind this coefficient the same as what's behind this coefficient? Yes. So these two are like terms. So 1 square root of 7 plus 1 square root of 7 is 2 square root of 7. Now the next one, 5 square root of 3 minus 1 square root of 3 is 4 square root of 3. Next one, 8 square root of 3 minus 4. Not 4 square root of 3. 8 square root of 3 minus 4. That's it. No, those are unlike terms. So I cannot combine those. 5 plus 3 square root of 11. You can't. I know that it looks like that would be 8 square root of 11. But the only way you could add these is if this had a square root of 11 behind it. Okay, now, let's look at this one. I don't think I let you, I think this one wasn't, I think this one was covered up. So copy this one. If you don't have this one down, copy it. All right, first thing you might would say is, well, we can't add those together. Why can't we? Because these are unlike terms. That is true. You are correct. We cannot add those the way they are. All right, so we're going to do something else with this in just a second. Remember back in earlier in this chapter, section 7 actually it was 7.1, I think, or the 7.2, 7.3, 7.5. Those that homework set that had 3 sections together. I taught you how to reduce a radical, and I told you, I said, whenever you write an answer, always make sure that every radical is completely reduced. Don't ever leave a final answer where one of your radicals will reduce. So, you are correct. Square root of 7 square root of 8 plus 3 square root of 50 cannot be added together. But what I've got to do is I've got to make sure that these 2 radicals are reduced. Now, why didn't I mention that in any of these other problems? If you'll look back at all the other problems, all of those radicals could not be reduced any farther. But watch what happens in this one. Let's look at this one a little closer. So, let's write this one back down. Question here. Again, first, can these 2 be added together the way they are? No. But, you say, okay, then that's your answer. It is if these 2 radicals are reduced. But question, is square root of 8 reduced? In other words, is there a perfect square that divides into 8? Yes, 4 will. So, rewrite 8 is 4 times 2. Now remember, if you're in the right mode, your calculator will do this for you. I don't care whether you let the calculator do it or you do it manually. That's up to you. Doesn't matter. Now, can I get to square root of 50? No. But is it divisible by a perfect square? Yes. 25. So 25 times 2. Now you got to bring the 3 down, and remember this is understood multiply. Bring the 7 down, this is understood multiply. Now break this into 2 radicals like we've been doing with all the others when we reduce it. When you break this into 2 radicals, you get this. Break it into 2 parts. Break it into 2 parts. Now, square root of 4 is 2. Now put a dot there so it doesn't look like 72. And then square root of 25 is 5. Put a dot there. But you can't get the square root of 2, so put it back under. You can't get the square root of 2 here, so put it back under. Now, 7 times 2 is 14, square root of 2. 3 times 5 is 15, square root of 2. So what have I done? I had to reduce those radicals because I can't leave it like this. Even though this is my answer, you can't leave an answer where a radical is not reduced. So this is the answer. But look at what happened. When I reduced these 2 radicals, it turns out they actually became like radicals now. They're like terms. They were not at the beginning, but they are now. So now, since they're like terms, this coefficient and this coefficient, what's behind this coefficient is exactly what's behind this coefficient. I can now add those 2 together simply by adding 14 plus 15, which is 29, square root of 2. So this problem here, I could not add or subtract them right out of the gate, but when I reduce these 2, it turns out that I could. Now, did I know beforehand that was going to happen? No. But I know that I had to leave my answer in reduced form, and then when I reduced them, I noticed that. Okay, so let's do another one like that. Okay. 2 square root of 75 minus 6 square root of 32 plus 5 square root of 27. All right, what are we doing? We're adding and subtracting 3 terms. What has to happen in order for you to add or subtract terms together? They have to be like terms. What does that mean? It means everything behind the coefficients have to be exactly the same. Well, the coefficient here is 2, the coefficient here is 6, the coefficient here is 5. What's behind this 2, what's behind this 6, and what's behind that 5 are all different. So that means you cannot add or subtract these together the way they are. So that's your answer. It's simplified. But if any of these radicals reduce, in order for me to get full credit, I've got to make sure that I reduce these. So that's my answer, unless these reduce. So let's look at it. Square root of 75 will reduce. Square root of 75 will reduce because 25 is a perfect square and it divides into it. 32 will reduce because 16 is a perfect square and it divides into 32. Now, there's other numbers that divide into 32 that's a perfect square. 4 goes into 32. But 16 is the bigger one, and remember we talked about this. If you use the bigger one, you only have to reduce it once. And then 9 is a perfect square and it divides into 27. So I will do just what I did in the last section. Or in the last problem, I'm sorry. Break this up. So this is 25 times 3, 16 times 2, and 9 times 3. Or use your calculator to do it. Now this time I'm going to cut out a step. What's the square root of 25? 5. Then I'm going to multiply it by that 2 to get 10. That 3 will stay under. Square root of 16 is 4. Going to multiply that by 6 to get 24. Going to leave that 2 under. Square root of 9 is 3. Multiply that by what's out front. 3 times 5 is 15. That 3 will stay under. So when I do that, this is what I've got. Now, that is the answer. They're all reduced, but look at what happened. When I reduce these, 2 of these now are like radicals, or like terms. 10 square root of 3 plus 15 square root of 3. I can add these together to get 25 square root of 3. However, I cannot add them with this term because it's a square root of 2. So this will simplify a little further. Now I have done 2 things. All of my radicals are reduced, and I've added and subtracted everything that I can. So when you look at that problem and you say, okay, I can't add or subtract these, make sure that your radicals are reduced before you leave that problem. Because sometimes in reducing your radicals, you all of a sudden will have 2 terms that become like terms that you can add or subtract. Now, if you reduce the radicals and that doesn't happen, then just leave that answer. But every radical has to be reduced in that final answer anyway. So this is how you add and subtract terms that have radicals in it. Now in this next section, next video, same section, we're going to look at how to multiply 2 terms that have radicals in it. Now the rule is different than multiplying with radicals and adding and subtracting with radicals. That's the same way with adding and subtracting and multiplying with variables. Like, what is 2x plus 7x? 2x plus 7x is 9x. But what is 2x times 7x? That's 14, not x, 14x what? Squared. Because the multiplying rule, you keep the base and add the exponents. The multiplying rule for polynomial terms is not the same as adding and subtracting. Well, you will see that's the case also with multiplying with radical terms. Multiplying with radical terms is not the same as adding and subtracting. So don't mix these 2 together. So we're still in the same section. We're about to go to section 7.4 video part 2 on multiplying with radical terms. So this concludes section 7.4 video part 1, adding and subtracting with terms containing radicals.